Hello guys, looking at question 2. The matrix 5b4 minus 1 maps the point A2 onto the point 28, 18, such that it can be expressed like this. Okay, so we can establish that this is a matrix related question. The question awards us with 4 marks to find the values of A and B such that this is all true. Okay, now so just to point a few things out that we've seen here, the information that we've given. This here is a matrix, and we can call this the network matrix. It has almost a transformation effect on the input vector, which is A2, and then it gives us our output vector. Okay, so it's almost like a function. In fact, it is a function. What it does is it takes a point, puts it in it transforms it and maps it then onto an output, which is this point here, and we need to find out the exact value of this element here, B, and the element in this vector, which is A. So in order to find that, we must realize when we were dealing with multiplying, say, matrix like a matrix by a vector, we would do it in a certain order, and I'm just going to run through that now, and perhaps in another video explain the more general purpose and more general rules, if you like, when it comes to multiplying matrices and vectors. Okay, so if we just write the vector out here, so we have 5 in the first element, B for -1, and then we multiply that by A2. Okay, so it's important to remember when we're multiplying a matrix by a vector that we do the row multiplied by the column. So 5a in the first element, we just have a little closed bit there, 5a plus the product of 2 times b, and then same again, rows again, 4a, and then -1 times 2, which is -2, like so. Okay, so that's the product of when the matrix is multiplied by the vector. The vector is multiplied by the matrix, and then we know that this transforms A2 to the point 28, 18. So that's the important thing to remember when we're doing this, and you'll probably receive a mark just for explaining that these are the same. Now, in order to find out our value of A and B, we must be looking now and not just dealing with matrices, but also looking at simultaneous equations. Now, this here, these two vectors are equivalent, but what does it actually mean, and how do we form this in sort of a way that's common for us to read? Well, as you would deal with normal equations, I'll just put a little asterisk down here, we would have 5a plus 2b is equal to 28, and then we have 4a minus 2 is equal to 18. Okay, so you can see the link here with this being equal to that, because this is the x point and this is the x point, this is the y point, and this is also the y point. So these are equivalent, these are equivalent. So continuing here, we have 2 unknown variables, a and b, and we want to find out what they are. So we'll look at either substitution or elimination. Well, because there aren't 2 variables in the second simultaneous equation, we're not going to be eliminating. So what we will do instead, because there is only 1 variable, which is a, we're going to try and get this variable a on its own, find out what it is equal to, and then we're going to substitute that into this equation. We're going to call that equation 1, and we're going to call that equation 2. So continuing with what I mentioned, so this is just a little arrow sign, nothing too important. So adding 2 to both sides to equation 2, we'll just highlight that here. So that will be 4a equals 20. Of course, adding 2 eliminates the -2 here, and then dividing out by 4, 20 divided by 4 is equal to 5. Okay, so that's one of our values of A, but how do we guarantee that it's correct? Well, first of all, we need to find out what our B value is when we are given when we substitute A. So substituting now into equation 1, where we have 5 times our A value, which we found to be 5, and then we're adding 2B, and that's equal to 28. So 2B, simplifying rather, the 5 times 5, which is 25. So 2B, we're going to substitute 25 from both sides. So 2B is equal to 28 minus 25. 28 minus 25 is equivalent to 3. Now we need to divide by 2 on both sides to allow 3 to be on its own, which is 3 over 2. Also 1.5 if you're dealing with a decimal number. We're going to keep it in fraction form for this question. So we have our two values A and B, and that we're only required to find those two values. If you want to verify that this is all correct, what you want to do, we'll deal with this little area up here, we'll write up here. What you will do is you'll substitute these values into the matrix, the network matrix and the input vector, and it should give you the output vector here, or the point if you like. So if we can do that now, or if you like, you can substitute them both into the simultaneous equations on both sides, and this should give you the value. So we'll do that now. Substituting both the A and B values into equation 1, we should get 5 times 5 in parentheses, add 2 times 3 over 2, and this, if you simplify it, so 5 times 5 is 25, plus 2 times 3 over 2, 2 is eliminate, gives us just the 3. 25 plus 3 is indeed equal to 28, which this is satisfied to this. And if we look at, this is equation 1, and if we look at equation 2, that should be the same as well. So we have 4a minus 2, so we substitute our value of a in here, minus 2, which would be 20 minus 2, which is indeed 18. Therefore, this is all satisfied. We know this is all correct, our value of A and our value of B. A is 5, and B is 3 over 2, also 1.5. We can substitute those into our little answer page here, and then we should be awarded the full 4 marks for the question. Of course, laying out your workings a little bit more methodically in the exam paper for the examiner to understand what you're doing at each point, and always making the important decisions, I guess, when it comes to when you're multiplying a vector by a matrix, always remembering the process and everything. Okay guys, so that's it at question 2. I'll see you in question 3.